Graphing systems of linear inequalities. Determining solutions of systems of linear inequalities. A system of linear inequalities consists of two or more linear inequalities that have the same variables, so like x and y. The solutions of a system of linear inequalities are all the ordered pair that make all the inequalities in the system true. Solve the system of equations by graphing. First, look at x plus 3y is greater than 3. The equation of the boundary line is, we're going to change that into slope-intercept form. Then we divide by 3. What are the x and y intercepts? The y-intercept is 0, 1, as identified by slope-intercept form. And the x-intercept, if I were to put 0 in the y's position, we would get 3, 0. Because x would be 3. The inequality symbol is greater than, so use a dashed line and shade above the boundary line for solutions that are greater than the inequality. So we're going to start at 1, then go down 1 and over 3. And we will use a dashed line and shade above. Now look at negative x plus y is less than or equal to 6. The equation of the boundary line is, move the x over, so we'll end up with y is less than or equal to x plus 6, and they want it written as an equation. Then it says, what are the x and y intercepts? Well, the y-intercept is 6. But if we put 0 in the y position, x would have to be negative 6, because negative 6 plus 6 gives us 0. The inequality symbol is less than or equal to, so we use a solid line. And we will shade below, since it was a less than or equal to. And it wants us to graph them on the same graph. So we're going to take the purple from before and the blue for this second one. For that second graph, it starts at 6, and it has a slope of positive 1. So we will go up 1 and over 1, creating a solid line, and then shade below. Identify the solutions. They are represented by the overlapping shaded regions. So this part here, where we have the purple and the blue, that is where the solutions to the system exist. If we just look at where it's shaded in purple, that is a solution to the first inequality, but not the system. And then if we look at just the blue, that is a solution to the second inequality, but not the system. And this section over here, that would be a piece of the graph where it is not a solution to either of the two inequalities. Now we will check our answers by using a point in each of the regions and complete the table. So we're going to look at each of those 4 sections. 0, 0. Is 0, 0 in the overlapping shaded section? No. So it's only going to be a solution to 1. So we'll figure out whether it satisfies the first inequality or the second. We'll plug it in. 0 plus 3 times 0, that's just 0. Is 0 greater than 3? No. How about negative 0 plus 0? That comes out to 0. Is 0 less than or equal to 6? Yes, 0 is less than 6. So it's a solution to the blue inequality. How about 2, 3? If we go over here to 2, 3, over 2, up 3, that is in the overlapping shaded section. So it should be a solution to both. 2 plus 3 times 3, that's 9, 10, 11. Is 11 greater than 3? Yes. Now we have negative 2 plus 3, that would give us 1. Is 1 less than or equal to 6? Yes. That is why it's a solution to the system, and it is in the overlapping section. Negative 8, 2. Negative 8, 2. That is in the empty, no shade section. So it should not be a solution to either inequality. So start by saying no, it is not in the overlapping section. Negative 8 plus 3 times 2. 3 times 2 is 6. Negative 8 plus 6 is negative 2, which is not bigger than 3. When you have a negative 8, that gives you a positive 8. Plus 2, that's 10. Is 10 less than or equal to 6? No, 10 is greater than 6. And then negative 4, 6. That is in the purple region, but not the blue, so it will only be a solution to one inequality. Negative 4 plus 3 times 6. 3 times 6 is 18. Minus 4 would be 14. And 14 is bigger than 3. Negative 4 gives us positive 4. Plus 6 is 10. But 10 is not less than or equal to 6. Why is 0, 0 a good point to use for checking the answer to this system of inequalities? 0, 0 is easy to multiply, divide, add, and subtract. So it is a quick point to check. If all you had to do was add a bunch of zeros together, you could solve it really quickly. So it's an efficient point to check. Solving systems of linear inequalities by graphing. You can use a graph of a system of linear inequalities to determine and identify solutions to the system of linear inequalities. Example 1. Graph the system of linear inequalities. Give 2 ordered pair that are a solution and 2 that are not. So they have these 2 inequalities in the system over here in A, and it says solve the first inequality for y. So you can see they moved that 6x over, changing it to a positive. Then they divided by 3 on both sides, and they got y is less than or equal to 2x plus 4, which is this solid line here, going through 4 on the y-axis. Then they graphed the second one. That one started at negative 3, and it's dashed. So that is that second one there. It says 0, 0, and 2, 8 are solutions. They are in the shaded, double shaded, overlapping shaded sections. 2, 8 is a solution because it is on a solid line. If it were on a dashed line, it would not be a solution to the system. Negative 6, negative 4 is not a solution, and negative 4, positive 4 is not a solution because both of those are not in the overlapping sections. In B, we start to do the work. So it says solve the first inequality for y. We will subtract the 3x over, and that would be our equation for the first one, or inequality, sorry. It says we have to find 2 solutions and 2 that are not. So we're going to start by graphing them. I'm going to do this first one in red. I will start at 1, and then I will go down 3 and over 1. Down 3 over 1, down 3 over 1. And that will be a solid line because it has the equal to symbol. And it is shaded below because it is less than or equal to. Then for the second one, we'll do that in green. We will start at -2 and go up 2 and over 3. Up 2 over 3. And that is a dashed line. And it is shaded above because it is greater than. For the solutions, we need to pick 2 points in this double shaded overlapping section. So we can use -4, 0. That is in there. We could use -8, 2. That's a point in the double shaded section. There's all kinds of points in there that you can choose from. I'm just going to list 2, but there are multiple correct answers that you can list there. Then we need 2 that are not. So any of the ones in the remaining 3 sections are not solutions. Only the ones in the overlapping part are solutions. So let's pick one from the green. Let's do 4, 6. That is not a solution because it's not in the overlapping section. And 7, -10. Go over 7, down to 10. That is not a solution because it is not shaded in either part. Then it says -6, -6. -6, -6. Is that a solution to the system? No, because it is a dashed line. If we put in -6 into that second inequality, we would end up with -6 times 2 is 12, -12, divided by 3 would be -4, so we'd get -6 is greater than -4 minus 2. But that comes out to -6 is greater than -6. It would be a solution if it had the equal to, but it is not greater than. So no, it is not a solution to the system. The system is the list of both inequalities together. Graph the system of linear inequalities. Give 2 ordered pair that are solutions and 2 that are not. We're going to start at 3, up 1 over 1, up 1 over 1. And it should be a solid line. And it will be shaded below. The next one, y is less than -3, is a dashed line, and it's going to be at -3 the whole way across because it has a slope of 0 in front of the x. And it is shaded below also. So we will list out 2 solutions in that double shaded section. We could do 2, -6, and -4, -4. And then the ones that are not, we could do -6, 4 is not shaded by either. And 10, 2 is shaded with red, but not blue. Now let's move on to number 4. We are starting number 4 at -8. And we will go up 1 over 1. And it is a dashed line. And it is shaded above with that greater than symbol. Now remember, these lines go on forever, and so do these shaded regions. So just because we only have a little portion of the graph, it can continue on infinitely out in both directions. This one we're going to have to solve it for y to figure out the slope and the intercept. So we'll move that 2x to the other side. And divide by 4. Two fourths reduces to 1/2. 16 divided by 4 is 4. So down 1 over 2, down 1 over 2. And that is also a dashed line. And it is shaded below because it has that less than symbol. All right, to find two that are solutions, we're looking in this double shaded section. The origin this time is a solution. And -5, 5 is also a solution. And then for the ones that are not, 10, 0 way out here is not a solution. And 6, 8 is also not a solution because it is just shaded green and not with both. Remember, there are plenty of points that are solutions and plenty of points that are not. So if you got something different than mine, that's okay. Just make sure your ones that are solutions are in that overlapping shaded section, and the ones that are not are any of the other sections. If lines in a system of linear equations are parallel, there are no solutions. However, if the boundary lines in a system of linear inequalities are parallel, the system may or may not have solutions. A shows an example where there is no solution. Because they are shaded in opposite directions, there is no overlapping shade. There is nothing that is double shaded, so there is no solution there. Now let's look at this one. In part B, we're going to start at -2 and go up 1 and over 1 and create a dashed line. And that is shaded above with that greater than symbol there. And then this next one, we start at 4 and go up 1 over 1, creating a solid line, is shaded below so the solutions are all the points between the parallel lines and on the solid line, or that green line. You can describe it as you drew it, or you can write the inequality down there. The solid line also has the solutions. Graph each system of linear inequalities and describe the solutions. We will start at -3 and go down 2 over 1 this is going to create a solid line shaded below. And then we will do the second one starting at +1 and going down 2/1. That will also be a solid line shaded below. And it also says describe the solutions. Well, the solutions in this case are the same as the solutions to the purple graph, because the purple and the red overlap in the same section as the purple already had. Then for 6, y is less than 1/3 x minus 6. So we're going to go up 1/3, up 1/3. And it will be shaded below. Then for the next one, we have starting at 5, up 1/3. And it is a solid line. And it is shaded above. So this one is a no solution because there's no overlapping section. Is it possible for a system of two linear inequalities to have every point in the plane as a solution? Why or why not? No. Each inequality splits the graph into two parts. So right away, you've chopped off half of the plane. That's why it was called a half plane. So each inequality splits the graph into two sections, eliminating points from the solution set. How would you write a system of linear inequalities from a graph? We would start by finding their slope and y-intercept. So write them in the form y equals mx plus b, essentially just writing the equation. But then we have to determine if it's shaded above, we would give it a greater than or equal to symbol. And if it's shaded below, we would write the less than or equal to symbol. And if it's solid, we would use these two. Or if it was dashed, we would use one of these two. Basically just working backwards. How does testing specific ordered pair tell you that the solution you graphed is correct? It helps us verify that the points are, in fact, in the overlapping shaded section.